In this video, we're diving into the history of coin sorting machines. Our journey through YouTube history will lead us to perhaps the most well-known project called Newman, created by Tim Rathjen. We'll talk about that project a little later in this video, but there have been several exciting developments in the realm of coin sorting machines over the years, and I can't wait to share them with you. The first machine is from Sales Acrofab, posted in September of 2014. This project is a precursor to some of the projects we'll see later, and you can see how many of them take inspiration from this prototype. The machine featured in this video uses a conveyor belt and is operated by pneumatic actuators. Coins are manually placed onto the conveyor belt and pass under a camera. When the camera sees a coin, an unknown algorithm identifies the size of the coin, and a pneumatic actuator is precisely timed to remove the coin from the belt and direct it into a designated bucket. If the coin isn't one of the three recognized, it simply rolls off the end and is collected in a final bucket. However, you can clearly see that the pneumatic actuators shown here are not well calibrated. In one instance, the force used is so strong that a coin is blown off the rails and nearly across the room. I hope they eventually tone this down a bit, as there's no need to fire these coins out of a rifle. For our purposes, this amount of force could potentially cause damage and lower the numismatic value of our coins, and that of course makes me a little bit sad. That being said, I think we can safely extrapolate the underlying functions of the machine from what we can see in the video. And what's interesting to me is that because it seems to primarily sort coins by size and possibly color, you don't necessarily need advanced AI for this. For example, within the Python library called OpenCV, there's a tool called the How Circle Transform. This tool enables the software to recognize circular patterns. When you have a darker background like the conveyor belt in this video, OpenCV can pick out circles and count the number of pixels. By doing this, it gets a rough idea of the coin's surface area and subsequently its size. Why does this work? Well, it's because the camera above the conveyor belt is fixed in both location and focal length. So if you know how many pixels the coin occupies, you can get a fairly good estimate of its size. Also, if you take an average pixel RGB color value over the entire surface of the coin, you can use that to figure out the object's general color. This works even better under controlled lighting conditions and with objects that are very different in color. So I think it's just kind of cool that you can set up this entire system without using any advanced artificial intelligence, machine learning, or image recognition algorithms. And as we've noted before in other videos, coins specifically can be sorted by size mechanically without even the need for a computer at all. That being said, I believe this video was posted simply as a demonstration of the ability to sort objects by color and size. Coins just happen to be a nice stand-in for this proof of concept. Hey everyone, it's Future Me again. I just wanted to take a moment to say that I've been doing some work on our website at thecoinbot.com. There you can find coin-related merch and get early access to my YouTube videos. I hope you'll get a chance to check it out and let me know what you think down in the comments. Our next video was posted in May 2017 and comes from Paul Crush. In this video, he delves into the world of lighting augmentation. While he uses pennies in this demonstration, his primary focus isn't sorting the pennies, but showcasing the capabilities of his algorithm for anomaly detection. What's truly remarkable about Paul's project is his commitment to open source principles. He generously shares both the software and hardware for his creation on GitHub. I've reached out to Paul directly, and in my interactions with him, I found it to be incredibly helpful, and he's provided valuable insights for my own project. Watching his video was truly enlightening. Paul takes a simple 28 by 28 pixel area of a coin, capturing just two sides of a single coin, one heads and one tails. With each of those, he adds 26 different lighting scenarios. From there, he programmatically applies various other augmentations, including rotation and adjustments to location. This process results in a dataset containing a whopping 57,000 images, all derived from just that single coin. What I find particularly exciting is how Paul's techniques relate to my own work. I've incorporated a similar approach into my own coin photo studio, using a pill bottle as part of the setup. Paul's project has been incredibly instructive and has given me a better understanding of what I'm striving to achieve in my own design. In July 2020, Andrew Consrow posted an intriguing project video on his YouTube channel. Andrew embarked on a mission to build a machine capable of flipping a coin and recognizing whether it landed on heads or tails. What makes this project unique is that he placed a big blue dot on the tail side of the coin, making it easily identifiable by the algorithm he employed. As discussed earlier, this one clever strategy eliminates the need for image recognition or artificial intelligence entirely. Instead, he can rely on the how circle transform in OpenCV to detect the circular shape and check for the dot. What I found particularly inspiring about this project was the coin flipping mechanism and the reset action. He took careful precaution during each cycle to ensure that the coin was over the flipping mechanism, but not perfectly centered. This ensured that the coin would spin more randomly and thus provide more accurate results. He noted that the machine is really noisy and takes a lot of time for an extremely large number of flips. Andrew's goal was to illustrate that a coin flip isn't truly a 50-50 proposition, and he provided some interesting statistics in the video description. From start to finish, he completed 10,040 flips, and that took a total of 6 hours and 15 minutes, averaging out to approximately 2.15 seconds per flip. To put things in perspective, flipping the coin 100,000 times at this rate would require nearly 2.5 days. Andrew also mentioned that the coin escaped the system approximately 10 times during this attempt, and this caused a few minor delays until he could put the coin back into action. In the end, the results were enlightening. Overall, he got heads 4,950 times, which is 49.3%, and tails 5,090 times, which is 50.7%. Andrew's endeavor showcases both the fun and the challenge of experimenting in a creative and informative way. Our next coin sorting machine is known as Newman and was created by Tim Rathjen. It's a fascinating creation that first came into the light in 2017 through several YouTube channels. In this video from Tim's channel, Newman appears to be running a group of quarters. But it's worth noting that there seems to be only one pneumatic actuator blowing coins off the belt. Later I'll show you a walk-around tour of Newman, where it's sorting pennies. This led me to wonder if Newman was primarily designed for sorting pennies, or if it had the capability to sort different types of coins. In a subsequent video on the Coin Week podcast, Tim mentions posting a poll to gauge interest in sorting and identifying other types of coins, further suggesting that its primary function might have been penny sorting.
We're doing wheat cents now, but we'll be able to pivot and then do Buffalo nickels and then Roosevelt dimes or whatever. What we want to do is we want to build as the users request. If I have 1,000 users, we do a poll and 1,000 users say the next coin they want us to do are Buffalo nickels, then we're going to go out and we're going to build the system for people to identify and evaluate Buffalo nickels.
This video, at least to my untrained eye, appears to be more of a timing test. As I mentioned before, precision timing is critical in these machines. It involves synchronizing the belt speed, the moment the coin is captured by the camera, and when it passes the pneumatic actuator. If the timing isn't exact, the machine won't know when to push the coin into the appropriate chute. Interestingly, in one instance, you can again see that the pneumatics are not yet tuned, causing it to blow a coin into the chute only for it to bounce right back onto the belt. This further suggests that this might have been more of a test than an attempt to sort specific types of coins. In April 2018, the YouTube channel CoinOp posted a tour of Newman where we finally see the machine in operation sorting pennies. Tim Rathjen added a whopping 20,000 coins, which amounted to 4 bank bags of wheat pennies, onto the conveyor belt, and the machine sorted them swiftly. Unfortunately, the video is poorly focused and shaky, making it challenging to grasp some of the finer details. However, in July 2018, Tim posted a much clearer video titled A Better Look at Newman. This video provides a more stable and better produced walk-around of Newman in action. It's evident that Tim put a lot of work into this machine, and he seems genuinely proud of it. Newman relies on numerous pneumatic actuators, pieces of rain gutter, 2 conveyor belts, 2 cameras, a coin hopper, and a coin pusher at the bottom that pushes coins onto the conveyor belt. Interestingly, Newman leaves the task of examining the sorted coins to the user, who can check their design and assess their true value. In the video, Tim claims to have located 4 1909 SVDB pennies using this machine, and he claims that it can do the work of 20 to 25 human coin sorters. While Newman is an impressive machine in its own right, it might be considered a bit of overkill for hobbyists due to its size and complexity. Nevertheless, it's intriguing to see how it inspired and influenced the direction of my own coin sorting robot project. It's worth noting that I have no information about Tim Rathjen's current status, but I'll attempt to find more information about the machine and its creator. And finally, folks, I want to talk about something that Paul Crush, who we discussed in one of our earlier segments, recently sent my way. He shared a video from Couch Collectibles where they were reviewing a fascinating machine called the Robo-Coin AI. Let me tell you, this device really caught my attention, and it aligns closely with what I'm striving to build. The Robocoin AI is quite an impressive piece of tech. It boasts the capability to sort various US coins, including quarters, dimes, nickels, and pennies. While it might not tackle dollar coins just yet, it's a substantial leap forward. What truly stands out is its proficiency in rotating the coins and recognizing their different types, ensuring they're properly oriented for sorting. I've only seen this one video, but again, I think we can extrapolate some of the details about how it operates. From what I can see in the video, the Robocoin AI does show some promise, but it also has a few areas where it could use some improvement. For instance, it seems to struggle a bit with identifying key dates on coins. This is an aspect that will eventually be fine-tuned in future versions. You'll notice that they are gathering customer coin images on their website, and I assume these will be used to more finely tune their machine learning algorithm. Another point to consider is that, at least in this video, it appears the machine may not be effectively separating high-value coins. I'm not entirely sure if this is due to the user error or if there's a limitation in the machine's design. It certainly piques my curiosity about how precisely the sorting process works, but I think it would be nice to separate the high-value coins from the face-value coins, instead of having the user stand there and try to grab them as they come out. It's also interesting that the robot design uses a lot of parts. That being said, they have much more than an MVP or a minimum viable product here, and they have clearly done great work. I'm definitely eager to find out more about the Robocoin AI, and I plan to follow Couch Collectibles' YouTube channel closely to stay updated on when this seemingly impressive machine becomes available for purchase. In this exploration of 5 remarkable coin sorting and coin-related machines, we embarked on a journey through ingenious creations, from coin sorters that harness the power of image recognition to machines that challenge our understanding of the classic coin flip. It's been fun, and I hope you found these projects as intriguing as I have. As we wrap up this video, I want to extend my sincere gratitude to all of you for joining me on this journey. Your support and enthusiasm makes this channel possible. For now, that's my 2 cents. Thanks for joining me today, and don't forget to like, subscribe, and hit the notification bell to never miss another adventure on this channel. Stay awesome, and I'll see you in the next video. Take care, everyone.